Okay, write down. A body is constrained. A body is constrained. A body is constrained to move along z-axis. A body is constrained to move along z-axis of a coordinate system. A body is constrained to move along z-axis of a coordinate system is subjected to a constant force. F is equal to minus I plus 2J plus 3K Newton.
The coordinate system
is subjected to a constant force. Is subjected to a constant force. F is equal to minus I plus 2J plus 3K Newton. Calculate the work done by the force. Calculate the work done by the force in displacing the body. Through a distance of 4 meter along z-axis. 4 meter along z-axis. That means force minus I plus 2J plus 3K. But displacement is along z-axis. That means 0I plus 0J plus 4 meter, 4K meter. Because that is only z component. Is there any doubt in that?
No, sir.
Then W is equal to
in displacing the body.
Displacing the body of along 4 meter. 4 meter along z-axis. 4 meter along z-axis. 4 meter along z-axis. Okay, now look. W is equal to F dot ds, F dot S. W is equal to minus I plus 2J plus 3K dot 0I plus 0J plus 4K. I 0, 2, 0, 3 into 4, 12, 12 joule.
Sir, cos theta.
Will you take cos theta here?
It is not there, sir.
No, sir.
We can
No, sir, sorry.
Fs cos theta you can take if you want. That means you have to find the magnitude of F, magnitude of S. Then theta you should know. Theta is not given.
Okay, sir.
Yes.
Is it over?
Yes, sir.
Yes,
Yes,
sir.
sir.
Mustafa, do you have any doubt?
Sir, it should be 12K, yeah.
No, sir.
12J. K will be 1, right?
Yes, sir, sorry.
It's a dot product. Answer is a scalar. K dot K is 1 into cos 0. Next question. Find the angle between the vectors. Find the angle between the vectors. Vector A is equal to I plus 2j minus k. I plus 2j minus k. And B is equal to minus I plus j minus 2k. Minus I plus j minus 2k. That is B. Find the angle between this.
A,
Have you written the question?
yes,
Now
sir.
we can write A dot B is equal to AB cos theta. That means cos theta is equal to A dot B divided by AB. Now we need to find out A dot B and AB, isn't it? Now A dot B is equal to, see, you can directly multiply, right? I dot I. That means minus 1. Any doubt?
No, sir.
2 here plus 2. 2 into 1j plus 2. Minus 1 minus 2 plus 2. Isn't it?
Yes, sir.
Yes, sir.
So that will be 3. A dot B is equal to 3. Now we need magnitude of A. Magnitude of A is square root of, first one you take, this one. 1 squared, that means 1, plus 2 squared, 4, plus minus 1 squared, 1. That means root 6. Isn't it?
Yes, sir.
Root 6. Now magnitude of B. 1's root of 1 plus 1 plus 4.
6 again.
That's again root 6. Now cos theta is equal to A dot B is 3 divided by root 6 into root 6. So cos theta is equal to 3 by 6.
Theta is equal to 60.
Cos theta is equal to half. Theta is equal to 60 degree. And arc integration, when you're doing, do it in a team, okay? Like if possible, 7, 8 students together, you do it. Something you discuss together, you can come on Zoom meeting and you can just discuss what you can do. It must be finished.
12th result came.
Okay, question. Prove that vector A, prove that vector A is equal to I plus 2j plus 3k, and B, and vector B is equal to 2i minus j, 2i minus j are perpendicular to each other. That means they should be 90 degree.
Cos theta should be 90.
Yeah. A dot B is equal to AB cos theta. Cos theta is equal to A dot B divided by AB. Cos theta is equal. What is A dot B? Take it A dot B. A dot B is equal to, here you can mark, see, this is 2, isn't it? First one 2. Second
Yes.
one minus 2.
Yes, sir.
Then this
Yes,
is
sir. Minus
0k. K
Yes,
is
sir,
not given
zero.
0k, so that will be 0. So the whole thing will be 0. So here
Yes,
A
sir.
dot B is equal to 0. Then let it be AB anything. Answer will be 0. Cos theta 0 means theta 90 degree. Isn't it?
Yes, sir.
Yes, sir.
Finish it. Hello, madam. Madam, what about result, madam? Now, 0, isn't it? A dot B is equal to 0.
Yes, sir. Yes, sir.
Okay, so this is 90 degree, okay?
Yes,
Fine.
sir.
Next one, find the value of lambda. Find the value of lambda so that, find the value of lambda so that vector A is equal to 2i plus lambda j plus k, and vector B is equal to 4i minus 2j minus 2k. Find the value of lambda so that vector A is equal to 2i plus lambda j plus k, and vector B is equal to 4i minus 2j minus 2k are perpendicular to each other. How will you solve it?
We'll take cos
We
theta is
take
equal
cos
to 90.
90.
That means 90. That means this product
Cos
will
theta
be
is 0.
0, sir.
this product will be 0.
It will be 0.
They are perpendicular to each other means A dot B. A
Yes, sir.
dot B, okay, is equal to AB cos theta. Since theta 90, A dot B will be 0. Okay, now you take A dot B. How will you take A dot B? This is 8, isn't it? 8 minus 2 lambda
Lambda
plus,
minus
this is minus
Sir,
2, right?
minus 2.
So equal
Yes.
to 0.
Sir,
Now we can get
Minus 2, sir.
minus 2, minus 2. Minus 2. Now we can say 6 minus 2 lambda is equal to 0. 6 is equal to 2
Lambda
lambda.
equals 3.
Lambda
Lambda
is
3.
equal to 3. Okay, finished. Next is cross product. Next heading, cross product. Cross product. Look here. See now, dot product, we understood when two vectors multiply, that product or result is a scalar.
Yes.
But cross product is different. When you multiply two vectors, again you will get another vector. These kind of product is known as cross product. One example I will tell you. Suppose this is a nut and bolt. You know nut and bolt? We used to fasten the
Yes, sir. Yes, sir.
missionaries.
Yes.
That's a nut and bolt. Suppose to unscrew this nut and bolt, this is an example. Like force, like work. This is another example for cross product. From here we'll go to the explanation of cross product. Look, there's a nut. Okay, placed in a machinery part or somewhere. We want to unscrew it. For that, we are using a spanner usually, isn't it? You know, spanner, right?
Yes, sir.
Yes,
Yes.
sir.
Yes,
We
yes, sir.
exert force onto this. Now, this spanner, we can say, here I'm marking, it's in x-axis. This spanner I'm keeping along x-axis. The force exerting in y-axis, isn't it?
Yes, sir.
Yes, sir.
Now
Yes.
here it makes a rotation in xy plane. That means spanner when I'm moving, I'm making a rotation in xy plane. Which
Yes,
direction this screw will come out?
XY plane.
Sir,
You come out in
It will
the
come
left
out.
direction.
It will come out, isn't it?
Yes, sir.
yes,
That
sir.
means it's the axis.
Yes,
Y
sir.
to Z axis.
This is the axis, right?
Yes, yes, sir.
Yes, sir.
Isn't
Yes,
it?
sir.
That means this force is a vector distant from this fixed point to the force. See, it is 90 degree. If you draw a line, there is a 90 degree direction come here. So this distance that called R, that's also vector. So product of that vector gives another vector.
Yeah, yes, sir.
This is known as torque. This is known as torque or moment of force. One full chapter you will study. 5th unit complete you are studying about it. Now I'll give a brief idea. Okay, so this kind of product is known as cross product. One example, torque. There are many examples you will study about this cross product. Now with one example, we will know what is this cross product exactly. Okay, listen now. So here, XY plane it is moving, result is outward. Now move reverse, you pull it down. This spanner, you pull down.
It will go in.
It will go in. That's what I'm saying. So when one side, if it's going, look at this, my hand. Okay, think of a screw, right-handed screw. Think of a right-handed screw like this. There are two types of screw, left-handed and right-handed. Think of a right-hand cutting screw. And this is the handle of the screw and this is the tip of the screw. Look at my right hand. This is a tip, this is the handle. I'm holding like this, okay? And turning like this. You see, this is XY plane. Handle is turning. Screw is going inward.
Yes, sir.
If I'm turning it opposite direction like this screw is coming outward. So direction of this resultant vector can be obtained by this rule, is known as right-handed Fleming's screw rule. This is a rule.
Yes, sir.
Sir,
Take a right-handed rule and turn it. Is it clear? Then
Yes.
because magnetic induction, that's the example of cross product. That's what using it there. That will see in 12th standard. Now we have to focus here.
Oh.
So this handle, while turning in XY plane, result will go in Z plane. If it go Y to X, it will go reverse. So with the help of this screw, we can find out the result, which direction that vector will move. Cross product, dot product, there was no such problem because dot product was a scalar. We don't have to think about direction. But here we have to think about the direction. Do you understand?
Okay, sir.
Yes, sir.
Yes, sir.
So if this is mainly connected with rotation, look here. If rotation, so here I told you right hand Fleming rule. Okay. So instead of using this screw all the time and turning, I will give a shortcut method. This method you can follow. Same way direction will be obtained. This is I, this is J, this is K. That means anything you turn from I to J, that we call I cross J. I to J means what? Hold the handle in X-axis and turn to Y-axis. Do you understand?
Yes, sir.
If I'm saying I cross J means hold the handle of this screw along X-axis and turn to Y-axis. Then which direction the tip will go? That's the resultant of the product. That is the direction of product.
Yeah.
Can you tell me which direction?
K, sir.
K. See, look at this circle. I cross J, K. You understood? Look at this circle. I cross J,
Yes, sir.
K.
Yes, sir.
Now, I cross J, K. Now, J cross I. Reverse, you see. Turn reverse. It will come out, right? So J cross I minus K.
Minus K.
Minus K. Reverse will come. Do you understand?
Yes, sir.
Same idea. Now, Y is Z plane. You take Y and Z plane. Y means J. This is K. So, J cross K. You see, J cross K will be I. Isn't it?
I.
Yes, sir.
Now, K cross J will be minus I.
Minus I.
Like that. So, using this one, this theory we can easily apply. You understood? Now, little more ideas I will give you about this cross product. Look, this one, because anyway, this we have to study in the future. That time I will not explain. Now itself I'm giving explanation. This you agree, this is a spanner. And you are exerting the force. So this is the length R. R means here we are considering distance from fixed point to this point where force exerting, that 90-degree angle. So force into this distance will give you rotational effect. That means the same force you are exerting here, it's not that easy. That means this place 1, here also I'm exerting 2, this is 3. Which point you exert force you feel easier to rotate?
The
First point. You can do an example, your door, room door, right? See, I will show you. Can you see this? Can you see this door? Can you see this door?
Yes, sir. Yes, sir.
Yes, sir.
That door handle, okay? After the class, you can do one thing. Hold at this point and push. At the same time, hold this end and push. Which you will find difficult?
So the one which
latter.
Which is closer to the fixed point.
Yes.
Clear?
Yes, sir.
That means here rotational effect can be easier when we are making the distance between the fixed point and the force is larger. But when you are exerting force, naturally it will rotate. Then new position of this spanner will be here. See, this is the new position of the spanner. Clear? Now again, force we are exerting in the same direction. Now you see perpendicular distance. If you are taking this much distance only now acting here, isn't it? That perpendicular distance.
Yes, sir.
You
Yes, sir.
understand? Now this is R. Am I right?
Yes, sir.
Yes, sir.
Are you getting the idea?
Yes,
Sir.
Yes, sir.
So now this distance, in this case, R means directly from here to here. R is here to here, that is R. But here complete R effective we will not get. The reason, look here, this is the direction of R. That makes an angle theta. If this is theta, this is also theta, right?
Yes, sir.
Then what will be this opposite side? It's a right angle
Sine.
triangle now.
Sine.
This will be R sine theta, isn't it?
Yes, sir.
Yes.
At this point, theta 90. Actually, this also you can take R sine theta. But since theta 90, we didn't write it. That is R sine 90 become 1. That's why this itself R. But here, effect of R, we will not get completely. Because sine theta is not 90. Now, the same spanner, if you are turning to this position, I will draw a little more clear. 1 minute. Look, this is the screw and this is a spanner I'm keeping here. Okay. This first I'm exerting force here and this, then I'm exerting the same thing to this point. I'm turning this spanner to, oh, that won't come. Okay. That is coming to this point. Same length, I'm turning here to here, it is turning. Okay, then it is going to this point. Here you are exerting force. Here you are exerting force. Here you are exerting force. Where you feel easier to turn this screw? Which place? This.
So initial
1, 2, 3. Where?
first
One.
At the place 1. That's why after turning this spanner, you'll take it out. And again
Yes,
you
sir.
fix horizontally. Again you turn. Again you
Yes,
take it
sir.
out, fix horizontally, again you turn, isn't it? Because you
Yes,
feel very
sir.
convenient
Yes.
when this distance from fixed point to the distance of the force is larger. So here when you're taking this place, there's a reference line I'm marking, okay? Look here. This is the distance from fixed point to the force. First case, this is the distance from fixed point to the force. Next case, let us see. Third case, this is the distance from fixed point to the force.
Yes, sir.
This distance. So in the first case, it is larger. Second case, that distance is reduced. Third case,
Yes, sir.
again reduced.
Yes, sir.
So the rotation of this object decided by 2 factors. First thing, force. Second thing, distance from fixed point to this line which I am drawing perpendicular. That called line of action of force. Is it clear?
Yes, sir.
Yes, sir.
Sir.
So that we can write, suppose this is the angle, here, this is the angle theta between force and the R. This is R, okay, force and the R. Then this also theta, this we can write it R sine theta, opposite side. So in general, we can write force into R sine theta decides torque. Torque is usually marked by the letter tau. Actually, this is T, went here. This is tau. Tau is a Greek letter. Usually, rotational effect of force or torque, we are representing by the symbol tau. So here we
Sir,
can
it
say
is not the
torque.
SI unit, right?
Torque is equal to force into perpendicular distance. This is a formula. Perpendicular distance from fixed point to the line of, that means this line, you see this blue line, green line I have drawn. The
Yes,
line
sir.
of action of force. This is the
Force.
formula for torque. That means in general we can write tau is equal to RF sine theta. We got work is equal to Fs cos theta. You remember?
Yes, sir.
So
sir.
dot product is connected with two vectors and cos. Cross product is the two vectors and sine.
Yes, sir.
This is storage of energy, but this is a vector. This is related to rotation.
Okay, sir.
And here, this RF sine theta, okay, that product you are getting is again a vector. If R in X plane, F is in Y plane, then torque is in Z plane. So that acting normal to XY plane. Normal means
Yes,
what?
sir.
If this is X axis, this is Y axis, this is normal to that. Normal means 90 degree to that plane. Isn't it? Do you follow?
Yes, sir.
So in order to indicate
sir.
that it is normal, usually we are putting a symbol like this, a unit vector. So unit vector I along x-axis, unit vector j along y-axis, unit vector k along z-axis, unit vector n. That means that is normal to a plane. Zaid Abdul, Muhammad Zaid, Muhammad Zaid, Muhammad Zaid. So did you understand this concept?
Yes, sir.
Yes, sir.
So usually torque we are marking like this. Torque is equal to R cross F. Here you see, torque is perpendicular to R. Torque is perpendicular
Yes.
to F. But
Yes,
R
sir.
and F are not necessarily perpendicular. Example, take case 1. See here, this R. See this perpendicular, that is perpendicular to this one. Isn't it? Torque. This 90
sir.
degree, right? These two?
Yes,
Yes,
sir.
sir.
Yeah, and just to transfer here, then you can understand that. This torque, just bring here and check. Force and torque are 90 degree, right?
Yes, sir.
Yes, sir.
This 90 degree.
Yes, sir.
Any doubt?
Yes,
No,
sir.
sir.
No, sir. No,
So
sir.
here, torque is perpendicular to R, torque is perpendicular to F. Now take case 2. Case 2. Here, torque, if you are taking, that is perpendicular to this again, right? Perpendicular to
Yes,
this.
sir.
Yes, sir.
And perpendicular to force again.
Yes,
If
sir.
not, I'll
But
show
not
you that.
but
Perpendicular. See,
R and
you can bring here. This
force
is
are
again
not
perpendicular, right?
perpendicular. Yes, sir.
Yes, sir.
These two are perpendicular.
Yes, sir.
But R and F are not perpendicular.
Not perpendicular. Yes, sir.
So this is a property of cross products. Sometimes they may ask you a question. So deeper I'm taking
Okay,
you
sir.
there. So keep in mind.
So what is that
Okay, sir.
N cap?
That is
Normal.
vector indicating this n cap, normal vector.
Not
Okay.
along any plane.
Not
That's
along.
normal.
Suppose screw is here. Spanner is here. Isn't it?
Yes, sir.
Yes, sir.
This is screw, this is spanner. Which direction screw will come out if it's rotating? It will come out this way, right?
Yes, sir. It
Yes,
will come
sir.
out this way.
This is indicating normal vector n.
Okay, sir.
Yes,
Got
sir.
it.
Unit value
Thank
of
you,
that is
sir.
not normal vector n. Is it clear?
Yes, sir.
So again, I'm telling you, look here. See, these are three positions. Okay. This is X. This is Y. Look here, this black pen indicating X. This is Y. This is Z. Isn't
Yes,
it?
sir. Okay.
Yes,
Okay.
sir.
Sir.
Agreed.
Yes.
So
Yes,
if
sir.
I'm turning
Yes,
this,
sir.
okay. If I'm turning from X to Y plane,
Yes, sir.
these two, this is perpendicular to this pen, right?
Yes.
That is perpendicular
Yes,
to this
sir.
pen.
Yes, sir. Yes,
If
sir.
I'm turning this also, this scale is perpendicular to these both, right?
Yes, sir.
Yes, sir.
These two pens are not necessarily perpendicular. That's what I'm saying you that.
Yeah.
Here all are
Yes, sir.
perpendicular. If you bring here also, these two are not perpendicular, but the scale is perpendicular to these both. Clear?
Yes, sir.
So these are the properties of cross product. That means cross product will be always perpendicular to the plane in which R and F rotates.
Yes, sir.
Yes,
Torque is
sir.
always perpendicular to R, always perpendicular to F. But R and F are not necessarily perpendicular.
Yes, sir.
Now, write down the notes. When two vectors multiplied, when two vectors multiplied, and if the resultant of the two vectors, and if the product of two vectors, and if the product of two vectors, and if the product of two vectors is again another vector, is again another vector, then this product is known as cross product. This product is known as cross product. If vector A and vector B are two vectors, if vector A and vector B are two vectors,
Sir, example.
acting at an angle theta, then cross product can be written as A cross B is equal to AB sine theta.
Sine theta.
Then
can you
cross
repeat?
product can be written as A cross B into AB sine theta, and here you have to mark a vector. This shows this AB sine theta product will be perpendicular to A and B.
Sir, A and B are two vector.
A and B are two vectors. Then its cross product can be written as A cross B is equal to AB sine theta, N, and a unit vector.
Sir, n cap will always be either I
Perpendicular
cap,
to
j
A
cap,
and
or
B.
k cap, right?
If A and B in XY plane, N will be in Z plane. Perpendicular to the plane, XY, perpendicular to a plane.
Yes, sir.
Yes.
Clear?
Yes.
Sir.
Now, here the direction of cross product. The direction of cross product can be obtained by right-handed Fleming's. Right-handed Fleming's corkscrew rule. Right-handed Fleming's corkscrew rule. Right-handed Fleming's corkscrew rule.
Obtained as? Sir, obtained by?
The direction of cross product can be obtained as right-handed Fleming's corkscrew rule. In this handle of the screw, the handle of the screw,
So can you repeat?
in this handle of the screw, indicate the plane of rotation of A and B, the plane of rotation of vector A and B, indicating the plane of rotation of A and B, XY plane, YZ plane, like that. Handle of the screw indicating plane of rotation of A and B, vector A and B. And the tip of the screw, this is the handle, this is the tip of the screw, indicate the direction of the product. Indicate the direction of the product. And bracket you write this also, okay? Because this you have to remember. This is actually another version of right-hand Fleming rule. I, J, K. Here you can mark
Sir, indicate the direction of?
cross products. Here you can mark I cross J is equal to K. J cross I is equal to minus K. J cross K is equal to I. K cross J is equal to minus I. This also you can put in the working column. For numericals, we need this idea. Have you written?
Yes, sir.
No,
Yes,
sir.
sir.
No, sir. The last one, sir.
Now just finish one example. Example, torque. And write an example, torque. Example, torque.
Sir, what's the symbol of torque?
Toe.
Toe.
So draw this diagram. This is R. Length of the arm makes an angle theta. This is fixed point O. Okay, this is F. This is R. These two are vectors. That makes an angle theta.
This diagram we have to
You have to draw this diagram.
draw.
This is a reference line, okay? It's a dotted line actually. When you draw, you should draw a dotted line. (90°) N. Okay. So this will be R sine theta. This is also theta. R sine theta. So resultant of this vector will be here. This is the torque. This is perpendicular to here and perpendicular to F. Okay. So your example, torque is equal to R cross F or torque is equal to RF sine theta. Thank you. So let me go after the results now. Okay, let me check.
Yes, sir. Check the result.
Learning.